What is the Saga pattern and how do we implement it? In this video, I'm going to show you how to implement the Saga pattern using the Rebus library and RabbitMQ as the message broker. Why do we introduce the Saga pattern? It's a pattern for solving data consistency across microservices or any kind of distributed system. We're going to use the example of publishing the order created event, which triggers sending of the confirmation email and then starting the payment request. For simplicity's sake, we don't have a distributed system, but we're going to make our implementation decoupled, and that will allow us to move the payment processing into a separate component in the future if we want to. I'm going to start by installing the Rebus library. So inside of the application project, I'm going to install Rebus. Rebus is a service bus implementation in .NET, and let's go ahead and install it. That's it for the application project. And inside of the web API project, I want to add a few more packages. I'm going to search for Rebus, and I'm going to install the service provider package. This is going to give us integration with dependency injection. Then I want to install the RabbitMQ for the message transport, and I want to look for the PostgreSQL Rebus library, which is going to use PostgreSQL as our persistent store. So let's go ahead and install that. The next step is going to be to introduce the RabbitMQ Docker image. Let's open up the Docker Compose YAML file, and I'm just going to add the required configuration for the RabbitMQ Docker image. The one we're going to run is going to be the RabbitMQ management, which comes with a management dashboard, and I'm going to expose the RabbitMQ port and the admin dashboard port. Now we have a RabbitMQ Docker instance configured in our Docker Compose, so let's go ahead and add the connection string inside of our application settings development file. I'm going to paste it in. You can see I'm using the host name from the Docker container, and this is going to allow us to connect to that instance when we start our application. Now the next step is to configure Rebus in our program file. I'm going to add configuration right below the call to add Carter, and we're going to call builder services add Rebus. This allows us to provide an expression for configuring Rebus, and let's configure the required components. So the first thing we need to add is the routing configuration. This tells Rebus how to route the messages that we publish over RabbitMQ. So we are going to use the type-based router. So I'm going to say type-based, and I'm going to tell it to map the types coming from the application assembly by calling MapAssemblyOf, and I can specify the application assembly reference type. And I also need to say which queue these messages should use. So let's create just a single queue, which we're going to call the eShop queue, and this is going to be the destination address for all of the messages that we publish. The next step is going to be to configure the message transport. So I'm going to call the transport method. This allows us to configure how we are going to send and receive messages. And for this, we want to use the RabbitMQ instance. So I'm going to say use RabbitMQ, and we need to pass it the connection string. We can pull that by calling builder configuration get connection string, and the name of our connection string is message broker. And we also need to pass in what is the name of the queue that we're going to use for sending messages, and that is going to be the eShop queue. Now we could be pulling all of these values from configuration, but I'm going to leave it like this just to make it simpler. The next step is to configure how our sagas are persisted, and for this we want to use PostgreSQL. So I'm going to say sagas, and then we say sagas store in Postgres. We need to pass in the connection string and the name of the tables where we want to store the Saga data. So I'm going to again use our application settings, and I'm going to call builder configuration get connection string, and this time I want to pull the database connection string. Then for the actual sagas, I'm going to store them in the sagas table, and for the saga index table, I'm going to say saga indexes. So this completes our Rebus implementation, and let's finally see how to implement a saga. So I'm going to add our saga inside of the application folder. So let's go ahead and add a new class, and let's call it order create saga. So something simple like this. Now to implement a saga, we need to inherit from the Saga class, which is coming from the Rebus library. So I'm going to say Saga, and you can see that this is a generic type. The generic type that we need to provide is a Saga data implementation, which implements this interface. So let's go ahead and define our Saga data. Let's say public class order create Saga data, we need to implement the ISagaData interface, and let's see what we have inside. So this interface has two properties, the ID of this Saga instance and the revision. So we're going to leave these as is. We can also introduce our own properties that we want to store inside of the Saga. So one thing I want to store is a GUID representing my order ID. So I'm going to add that. And then you can store additional steps to tell you where you are in the Saga. So let's add two flags, which are going to be Boolean values to signify which step we are in. So we have two event handlers, one for sending the confirmation email and one for creating the payment request. So let's say that the first step is to send a confirmation email, and then we want to trigger sending the payment request. So let's say welcome email sent as one step in the Saga. And for the second step, we're going to say public bool payment request sent. So this takes care of the Saga data for our order create Saga. So let's move that into a separate file and let's focus just on the Saga. So I can now specify the order create Saga data and we can implement the interface. So now we have to implement this CorrelateMessages method. It allows us to connect the messages that we receive through Rebus with this Saga instance. So now what we are missing is the actual messages. We already have the order created event. So let's get rid of the iNotification implementation and let's even replace this with just order ID, which is a GUID. So we're going to simplify this event even further. Now let's think of what other events we want to introduce. We want to have an event for each step in the Saga. One event was that the confirmation email was sent. So we're going to create a respective event that the order confirmation email was sent. So order confirmation email sent. The next event that we have is the payment request event. So let's say order payment request sent. And again, we're going to use the order ID. So these are the events that we want to handle in our Saga, but we also want to be able to publish commands to call the next step in the Saga. So we're going to add that in just a moment, but let's go and finish up our Saga. So after the Saga implementation, we need to implement the IAmInitiatedBy interface to tell which message is going to start the Saga. This is going to be the order created event. And then for each step in the Saga, you implement the IHandleMessages interface. So one message that we have is the order confirmation email sent. And the other message that we have is the order payment request sent. So these are all of the messages that we need to implement. Let's add the missing members. We are going to implement these later. Let's focus on the CorrelateMessages implementation. We need to configure for each of these messages how they correlate to the Saga instance. So I'm going to say correlate, and I'm going to use the order created event. And I just need to provide two expressions. The first is which field we are going to use on the message to correlate to the Saga. And then I need to write a second expression to say which field on the Saga we are correlating to. So in both cases, this is going to be the order ID, and the same holds true for the other two events that we have. Now I want to implement the method for handling the order created event. So what I'm going to do is I'm going to inject the iBus instance coming from Rebus, which is going to allow me to send messages over the queue, and then I want to implement this method. I'm going to say if the Saga is not new, so I'm going to say is not new. All right, then I just want to return because we received a duplicate message. Otherwise, I want to send a message over the bus, which is going to invoke the next step in the Saga. This message instance is going to be a command and not an event. I'm just going to add it here so that you can see them all in one place. We're going to call this command send order confirmation email, and we're going to give it the order ID. Now I go back to my Saga and I can send this command. So send order confirmation email, and I can pass the message ID either from the message, or I can use the data of the Saga and pass the order ID from there. So let's, for example, pass it from the message, and this is now going to send this message over the queue, and it's going to invoke the respective handler. The handler for this is supposed to be the send order confirmation email event handler. So I'm just going to rename this to be send order confirmation email handler, because this is now a command handler. Let's rename the file, and we're going to implement the IHandleMessages interface, which comes from Rebus, and the message that we are handling is the send order confirmation email. So let's go ahead and implement this member. We need to replace the iLogger argument here, and of course the constructor. So inside of the handle method, I'm going to use what I already had here. We're just going to log before and after sending the confirmation, which is going to await for 2 seconds to simulate that we are sending the email. I need to make this asynchronous, and I'm going to get rid of the old implementation here, and we need to replace this with message. So now, after having sent the order confirmation, I need to publish another event to the queue to say that I have completed this event. We already created this event, so all we need is to inject the instance of the iBus. So let's go ahead and add that, and we're going to eject it from the constructor. And now in the handle method, I can say await bus, and I can send the message, and this is going to be the order confirmation sent message, and we're going to use the order ID to be able to correlate back to our Saga. So now this message is going to hit our handle method in the Saga, which is going to be this one, and then we can update the Saga data and invoke the next step. The next step is going to be updating the data of the Saga. We need to set confirmation email set to true, and now I can publish another command for invoking this step for sending the payment request. So I'm going to make this asynchronous. We're going to copy this from here, and we're just sending a different command. The command that I'm going to create is going to be the create payment request command. So let's say public record create order payment request, and we're going to give it the order ID. Now I'm going to send this command from my Saga. So here in the handler of the order confirmation email sent, and this is going to invoke the respective handler of the create order payment request message. The handler is going to be our create payment request handler. So I'm going to rename it slightly. We need to implement the IHandleMessages interface. So IHandleMessages, and we need to specify the create order payment request. So if we implement this interface and fix the few compile errors that we have, we can now implement our handle method. And I'm going to use the same approach as before, where we are simulating the starting of the payment request with an asynchronous delay of 2 seconds. And after having completed the sending of the payment request, we're going to publish another message. So I'm going to inject the iBus here from Rebus. So private read only iBus, and we inject it from the constructor. And now I can say in the handle method await bus, and we send a new message. The one we want to publish is the order payment request sent. So we're going to give it the order ID so that we can correlate back to our Saga. And finally, if we go back to our Saga, we just need to implement this last handle method. I'm going to do 2 things. One is we need to update the payment request sent to true. So this updates our Saga data to say that it is completed. And then to complete the Saga with Rebus, we need to call the MarkAsComplete method, and we can just return a completed task. So the call to MarkAsComplete is going to mark the Saga as completed, and it's going to delete it from the database because we are done processing. So let's take a look at our complete Saga implementation here. This implementation of the Saga pattern, where we have a central class orchestrating the individual steps of the Saga, like we have here, publishing the respective commands, is called the orchestrated Saga pattern. This is because we have a central component that handles all of the messages and invokes the next part of the Saga. Before we can run our Saga, we need to add just one bit more of configuration. We're going to call builder services, and we need to call the auto register handlers from assembly, and I'm going to pass it the application assembly, and Rebus is now going to scan my application assembly and configure all of the message handlers that we implemented. The call to add Rebus here is going to add a background service that is going to take care of running our service bus instance, but we need to manually configure which messages we are subscribing to. I'm going to pass a function in the onCreated parameter. This is going to be an asynchronous function accepting an iBus instance where we can subscribe to the messages that we want to handle. To subscribe to our events, we're going to call bus subscribe, and we're going to specify the order confirmation email sent, and we're also going to subscribe to the second event that we have, which is the order payment request sent event. So now our Rebus instance is subscribed to these messages, and the last bit that we need is inside of our create order command handler to actually publish a message using Rebus and not Mediator. So I'm going to get rid of the iPublisher here, and let's add the iBus instance from Mediator. So let's inject it from the constructor. I'm going to remove the iPublisher that we had previously, and now we just need to send the event using the iBus instance. So I'm going to say bus send order created event. We're going to pass it the GUID value, and we don't have a cancellation token. So let's see how our Saga works. I'm going to add a breakpoint here, and we're going to send a request from Postman. I'm sending a post request to our API, which is first going to create our order. You can see we hit the breakpoint inside of the create order command handler. So we're going to fetch the customer, create an order, persist that in the database, and then we're going to send the order created event. I'm going to press continue. You can see we hit the handle method in our order create Saga. So this is the first step in our Saga. We can check if the isNew is set to true, and it is because this is the first time that we're handling this message. So now we send the send order confirmation email command, and this starts the next step in our Saga. So if I press continue, we're going to hit the send order confirmation email handler. We're going to send the order confirmation, and then we send the order confirmation email. So I'm going to hit continue again. We're going to wait for 2 seconds, and we hit the handle method back in our Saga for the order confirmation email sent event. We update our Saga data that the confirmation email was sent, and then we send the create order payment request message. This is handled in the respective handler. This is going to complete and send the order payment request sent message. We're going to wait for 2 seconds again, and we are back in the last step in our Saga, which handles the order payment request sent message. We update our data, we set the payment request sent to true, and we mark the Saga as complete. So I'm going to switch to my dbeaver instance to show you the Saga table. You can see we have the Sagas here, and this is the Saga that we are currently running. So when we complete the Saga, this will be removed. If I go back to the application and I press continue, this is going to complete the Saga. The Saga is now completed, and if I hit refresh, you're going to see that it is removed from the Sagas table. If you want access to the complete source code for the Saga pattern implementation and all of the previous videos that I have, you can do that by supporting me on Patreon. Make sure to smash that like button, subscribe to my channel for more videos like this one, and until next time, stay awesome.